Okay, our objective for this lesson is how to evaluate limits at infinity. We'll be working out a 12.4 in your book. That's page 835, entitled Limits at Infinity. So as we start talking about infinity, just think about what infinity is. Infinity, to me is a concept that essentially means never ending. As kids, we always said, what's the biggest number? And we kept naming higher numbers until somebody yelled infinity. And even sometimes we got into infinity plus 1, infinity plus 2, and so forth, which brings us, how do we do math with infinity? So let's think about performing math calculations using infinity. What would happen if you multiplied infinity by numbers such as 3? What is 3 times infinity? Or what is negative 3 times infinity? Well, since infinity is such a large number, if you triple it, it's still infinity. It hasn't changed. I mean, it's more of a concept than a number. It's just that huge. Now, if you multiply by negative 3 to infinity, so I'm sorry, negative 3 times infinity, well, negative times a positive, well, that just gives us a negative infinity. What about addition and subtraction? What is an infinity plus 4? Well, infinity, again, such a huge number, it's never ending. If you add 4 to it, 4 compared to infinity is nothing. So adding 4 does not change it a bit. It's just infinity. Take away 100 or 1,000 or a million. It's still just infinity. Infinity is that big. Now, division, on the other hand, we have to think about a little bit. If you took infinity and divided it by 1,000 or a million or 100 million or a billion, again, since infinity is so big, dividing it by that much doesn't really change it much. It's still infinity. However, if we took a number, any number, I chose 1, but you could choose 10, 100, 1,000, a million, anything, any number in the numerator, and you divide it by infinity, well, all of a sudden, the denominator is so much bigger than the numerator. And I don't care how big you make the numerator, excluding infinity, how big you make it, which number you choose, when you divide it by such a big number, the denominator is so far or so much bigger than the numerator, this is a really tiny number. 1 over infinity, in fact, is so tiny, we call that 0. So that's a concept we have to look at as we start evaluating limits at infinity. When we apply our direct substitution, we may be called to add or multiply, or we may be dividing by infinity. So we have to kind of look at this concept and see what's going on. Okay, let's take a look at our first example. This is find the limit as x approaches infinity of the expression 4 minus 3x squared. Now looking at this, if I kind of look ahead with direct substitution, I'm going to have 3 divided by infinity. Okay, so we kind of got to think about that. We just kind of went over what could happen. So let's kind of look at the process on how to handle this problem. Okay, our first step is we're going to apply some properties that are actually found on your text on page 811. You can go back and check them. But when we have an expression we're trying to take the limit of, we can split it up into 2. Very similar to the logarithm stuff we did a few months ago. So we have the limit as x approaches infinity of 4 minus the limit as x approaches infinity of 3 over x squared. Okay, we're also going to use another property found on page 811 that says I can pull the 3 out of the numerator and put it out front. It's a scalar multiple, so we're left with the limit as x goes to infinity of 4 minus 3 times the limit as x goes to infinity of 1 over x squared. Our main concern is the part with the x in it because that's where our direct substitution happens. Now our next step is to take the limit. So as we take the limit using direct substitution, we substitute infinity and we have 3 times, or let's back up, we have the limit as x goes to infinity of 4. Since there's no variable, it's simply 4. It's the constant. It doesn't change. Minus 3 times. Now as I take the limit of this piece, we have 1 over infinity squared. Now, squaring infinity is still just infinity. However, since it's in the denominator, that 1 over infinity becomes 0. And using order of operations, we can say that our limit as x approaches infinity of this expression is simply just 4. So take a minute, wrap your head around it, and we'll move on. Okay, we're going to move on. If you have any questions on something I did and not quite sure, go ahead and jot them down to the side. And tomorrow when we go over this, you can ask them and we can clear it up then. Okay, our next example. Now here we have a rational expression. We have the limit as x approaches infinity of negative 2x plus 3 all over 3x squared plus 1. Now to tackle a problem like this, we have to look at it a little bit different. We're not going to split it up using properties. What we're going to do is we're going to divide both the numerator and the denominator, so it's all terms in the numerator and all terms in the denominator, by the highest power term in the denominator. So we're going to locate the highest power term in the denominator, in this case would be the x squared. And then we're going to simply divide everything in the numerator by x squared and everything in the denominator by x squared. Okay, so once we do the division, we just clean it up with some simplification. So cross out some x's here. This one just leave as it is. The x squared in the denominator goes away, and this is 1 over x squared. So once we simplify, we simply take the limit. And that's what we're going to do next, take the limit. So by direct substitution, we substitute infinity everywhere we see x, and then we analyze what's going on. In the numerator, the first term, negative 2 over infinity, is negative infinity. Back that up. That's not negative infinity. Negative 2 divided by infinity. So we have a negative number with a really big number on the bottom. That's just approaching 0. So that becomes 0. Same as the second term in the numerator. 3 over infinity squared is just 3 over a really big number. Again, that goes to 0. The denominator, 3's by itself, plus 1 over a really big number. Again, that goes to 0. So all three of these will go to 0 because they're fractions that are very tiny and approach 0. So as we take the limit, we have 0 plus 0 over 3 plus 0, which in turns, hey, equals 0. So the limit as x approaches infinity in this expression, it's simply just 0. So take a few seconds to wrap your head around it and jot down any questions you might see or have that you need answered tomorrow. Okay, moving on, the last problem I want you to try on your own, and this is something I could collect tomorrow and say, hey, give me your problem as a homework trick. All right, we're going to evaluate the limit as x goes to infinity of negative 2x squared plus 3 all over 3x squared plus 1. Now you might notice this example is very similar to the last example, but they are a little different. So let's kind of take a look. The first thing I'd like you to do is identify the highest power variable in the denominator. Okay, once you've determined what that is, I would like you to take that variable and divide all terms by it in the numerator and denominator. Simplify it, cross-canceling some x's, and then lastly, I need you to take the limit as x goes to infinity, so plug them in and decide what's happening. Is it going to 0? Is it going up to infinity? And then I want you to interpret your answer and see what you come up with. This will be a problem we'll talk about when you come back. So come to class, have your notes ready, and be ready to talk about this problem and any questions you may have.